Thank you for that kind invitation, and we appreciate the invitation to speak. I think we're basically presenting in two capacities today. The first is as a group that is interested in developing novel tools in this space that are useful. But then the second capacity is as two stakeholders in an institution that's been working quite hard on developing an enterprise-wide capability to deploy tools that are explicitly intended to change how we work or how we reason or what we understand about patients. So many of the specific insights that I offer are maybe more associated with that second role. I wanted to start by talking a little bit about our specific application domain and set of research questions. As you heard, I'm an intensive care doctor. This is what a bed space in the cardiac ICU looks like now. It's an almost dystopian environment. We are technologically very complex area of critical care. We utilize multiple devices, typically in concert, to support critically ill patients, and we have to reason in environments that look like this. And a lot of what we're trying to infer in environments like this is what the patient state is, the underlying patient state. In an environment like critical care, that state fluctuates very dramatically and over multiple different timescales. Sometimes patients are very dynamically evolving over the course of seconds instead of minutes. Patient state is a latent variable. It's something we can't directly measure from the available data, and we have to infer it from the data that is available to us. So in other words, we measure really what we can rather than what we want to. And this is an area of medicine where we engage in what's known as naturalistic decision-making. In the naturalistic decision-making paradigm in medicine, you're essentially relying on your stored experiences and intuition to a much greater degree than on the kind of high-quality information that emerges from things like randomized controlled trials. ICU patient populations are all outliers, and a combination of that outlier condition, their uniqueness, their stochastic behavior tends to make them relatively resistant to randomized controlled trials. And so, unlike deterministic decision-making, virtually all of the decisions we make are far from certainty and far from control. That environment that I showed you represents one of the ways we try to navigate that problem. We try to address the uncertainty of individual decision-making at the level of the individual patient by, in essence, drowning ourselves in data. But even that isn't a very effective strategy. Cognitive neuroscience talks about this 7 to 11 variable problem. And basically what it describes is how the typical human brain can only simultaneously process 7 to 11 variables to reflect on any given problem at any given time. And what that means is that if you're above that theoretical threshold, any additional data is noise rather than information. And this is a way of trying to provide a context for why we think deployable analytical solutions in this space are so important. In talking about how we went about it and how that informed our experiences, and this was an experience that Melissa was also part of when we were all working together at SickKids. Data sampling frequency in medicine matters a great deal, depending upon what it is that you intend to do with that data, as far as it pertains to state estimation. And that's because data sampling frequency affects your ability to understand states that evolve over varying time sort of intervals. As an example here, if I asked you to describe the movement that this individual's engaged in and only provided you with the first and last frames, you would miss much of the richness of the movement in between and probably not be able to describe the aggregate movement. Simultaneously, or similarly rather, in medicine, sampling frequency affects the accuracy of our ability to estimate state and understand these intermediate or transition states. When we set out to work on this problem a little bit more than a decade ago now, there weren't good solutions for this. We were interested in very, very high frequency data with the idea that continuous data allowed us to continuously estimate patient state. And Andrew Goodwin, who's on this call, led the development of a technical system that we used to do this work. And I think that this is relevant to this presentation because the absence of a technical solution meant that this was an end-to-end effort. We had to essentially develop a a vendor-neutral archive that allowed us to pull in signals from the kind of complex bed spaces like the one I was just showing you, and represent them in a well-conserved format that we could affordably store, and then be able to make that data available for secondary use. So be able to stage and pre-process the data, reason on it, and then ultimately, and this was one of the ways that Dmytro got involved in this work, be able to actually deploy models that reasoned on this data in either real time or near real time. And so it was sort of an end-to-end experience of the many challenges associated with doing that. And as I said, we intend to continuously estimate state, and this is what that data looks like. This is 3 specific physiologic signals, time synchronized with one another, and looking at this data over a variety of different time scales is useful. This is 5 minutes of the same data with the 2 seconds that I just showed you from that patient being here. Allows very granular insights to look at this if you're trying to sort of drill down and understand, in this case, a critical event. This is a patient experiencing, in fact, that very same patient experiencing cardiopulmonary arrest. Decrease in the amplitude and frequency of the arterial signal is hypotension and bradycardia. The patient has an arterial waveform, arrest onset here. Massive excursion of the chest wall, so chest compressions. Receives a dose of epinephrine here, which restores perfusion pressure, and there's what's known as a return of spontaneous circulation. And so you can anatomize, if you will, clinical events at a sub-millisecond level, which is very, very useful in developing and not just an understanding of these events, but also very, very accurate annotations. But I show this because a lot of hemodynamic behavior, patient hemodynamic behavior, is very patterned. The combination of this very high dimension continuous data and these very, very patterned patient behaviors also explains why this kind of data is a natural substrate for machine learning. This is an example of a very classic approach to machine learning that has been a longer term interest of our broader group, heart rhythm annotation in real time. But we also try to use this data to directly solve that problem I was describing at the beginning of the talk, which is infer patient state. So in other words, measure what we want to rather than what we can. This is a model developed by a friend, collaborator, and real innovator in the modeling space, Danny Aitan, known as ICVS. It essentially is a model that capitalizes on existing biophysical understanding, develops a simplified representation of the circulation, heart as a single chamber, organ space as a single space, an arterial and venous compartment, and then uses ordinary differential equations to solve for different circulatory states. I'm showing this because this is actually tactically the first model that we have chosen to deploy here in Seattle. Danny has deployed this model already at his home institution in Rambam, and is representing the output of this model as both a time series and then as a set of essentially consumable integers that reflect on these latent variables that describe the circulation. And we made a decision to deploy this model first for multiple reasons. The first being that we thought that it was a very reliable model based upon the experience both at SickKids and at Rambam. We also thought that this was a model that would serve as something of a soft introduction to consuming models and using models for decision-making by virtue of the fact that it is very explainable. Because it capitalizes on existing biophysical understanding, we thought that it would be immediately useful to clinicians. But it's also a scaffold, and it's a scaffold for what we hope will be biophysics-informed machine learning. In the physical sciences, and engineering is central here. There's a real vogue right now for physics-informed machine learning, and the concept behind physics-informed machine learning is that you develop hybrid models that have the expressive power of machine learning, but also are able to enforce the constraints of physics, and ideally result in much more accurate representations of physical systems that are also much more explainable. So in other words, the best of both worlds. It's a testable hypothesis whether this will be as useful in medicine, but it's a hypothesis that we intend to pursue. And that's because, traditional machine learning, we treat the data as though it comes from an unknown process. But in fact, we know a great deal about the data generating process and can use that to inform and improve the performance of our models. I mentioned this sort of longitudinal annotation of time series because if I sort of zoom out and think about what our ultimate goal in all of this work would be, is it's to enrich our time series with annotations from other aspects of the electronic health record, recording and time synchronizing the output of performant models in a way that creates for us a very context-aware time series that we can use for causal reasoning. And the utility of that as a clinical tool in the work that we do would be being able to reify our existing knowledge by measuring the strength between inputs in the form of clinical interventions and outputs in the form of the resulting patient states. So in other words, validating for us that the things that we do are going to be consistently helpful and reliable in improving patient state. I also think that one of the very interesting utilities of this approach is the ability to explore counterfactuals. So, what if I gave 4 times as much epinephrine? What if I gave it twice as fast? And extract from this observational time series the same kind of insight that we have traditionally relied on randomized control trials to give us, but not again at a cohort level, at an individual patient level. So that's essentially for us the holy grail. But I think that the work that you do has to be context aware in other ways too. And as you heard at the beginning of the presentation, we're in Seattle in Washington, where the blue dot is. The heart center that I'm responsible for and Dmytro and I work in is a very large regional program. We have an obligation not just to project care over a 5-state area routinely and a 6-state area for specific populations like VAD and transplant. We also have an obligation to project that care out over the North Pacific, so all the way up to Alaska, Hawaii, the Marshall Islands. And this creates for us additional, not just obligations, but potentially opportunities. I was describing how watching and understanding and annotating how patient state evolves over minutes to hours or seconds to minutes to hours is useful. Similarly, looking at much longer time scales for patients as they grow or change, so months to years would be useful. And in the same way that we try to capture data from every device with a logical connection in the hospital, we are in the process of working through a variety of specific use cases that involve using the Internet of Things, some of the many devices that capture increasingly high quality medical data with the goal of being able to not just estimate patient state ideally over longer windows of time, but provide clinical useful annotations or alerts. These monitoring devices improve all the time. This is an example of how small silicon electrodes have gotten. This thing is transferred currently in addressing the next generation of this device, I understand, is going to be placed like a temporary tattoo, like the temporary tattoos children wear, and can be used to monitor an EKG and respiratory impedance, or movement of the chest wall, for not just weeks, but months at a time. One of the traditional challenges with the concept of remote monitoring, which is what I'm talking about here, is that the amount of data increases dramatically, and you can create a false sense of security. The question is, who's monitoring that data? We are currently interested in exploring a variety of ways that we potentially could measure clinically relevant change points in this data as a way of providing essentially what could be considered a smart alarm to clinicians about relevant changes in patient condition. And this is one example of that kind of technique with reference to a single lead EKG, which can then be decomposed into a point cloud, allowing the measurement of a Wasserian distance that identifies a clinically relevant change as a change point in this patient's EKG morphology. The animating sort of principle behind this work is a philosophical question, and it's the question of whether we should understand hospitals in this sort of paradigm that technology now enables as physical locations, brick and mortar structures, or whether they're socio-technical capabilities that we can project over great distances. So in other words, be able to make the same kind of high quality decisions and obtain the same kind of high quality information about patients here at Seattle Children's as we can here in remote Alaska, more than 1 million miles away. So that's a brief orientation to the specific work we're interested in. But to now sort of pivot to the second half of the talk, which is concordant with the title. Dmytro and I have had the unusual experience of moving to a new institution with basically a combination of a mandate and a desire to establish this enterprise capability that's really focused again on translation, with the opportunity to try to implement lessons that we learned over a period of time working on this problem with Melissa and Andrew, among others, at SickKids. And we wanted to summarize what we think some of the key strategic steps we are taking to try to operationalize those lessons, not with the suggestion that we have in any way solved this problem, but with the goal of starting a conversation and receiving feedback and suggestions. I'd say, the first observation is I described how when we started to work in this space, a lot of existing technologies weren't configured to facilitate the development and deployment of models. And so we had to develop this end-to-end system. One of the key developments over this interval is that tools, clinically available tools that are actually widely disseminated in clinical practice, have substantially improved. And I'll pass this off to Dmytro to describe exactly what those capabilities look like around pragmatic deployment with reference to 2 systems that we use here as examples.
Thank you, Jai. So initially, when we started this conversation about how we can implement AI models at Seattle Children's, we were thinking that we would probably need to do everything from scratch. We were not thinking that we were thinking that everything starting from data collection to data engineering and getting the pipelines up and running, cleaning the data, organizing the data, unifying it, and then developing the models, training them, validating and deploying, including building out visualization platforms for clinicians to start using it, that we would need to focus on all of these at once. And of course, it's a big effort. We didn't know how to get started. So the first thing we decided to do is just look at what resources are available for us that we could potentially leverage to focus on our core competency as opposed to trying to build everything. And turns out that actually there's a lot that we can rely on already that is actually already used clinically by the bedside or in daily clinical practice. The tools that already allow the work, the modeling work that we're doing to be directly served to the clinician and support their clinical decisions. And these systems right now, they allow predictive insights, they allow risk scoring, they allow data-driven workflows to be displayed directly in, for example, patients' charts in the EHR records. They allow that to be displayed by the monitors in the ICU setting. So the challenge is no longer whether the infrastructure can support modeling or whether we need and how do we need to build this infrastructure. It's rather what tools are available and how can we leverage them most effectively. So with this in mind, we had 2 systems, as Jai mentioned, Epic and Idiometry, that just very 2 specific examples to our environment over here. But we hope that those serve as an example for you to investigate the systems that your institutions have accommodated and have deployed that you could also use for your specific use cases. So we'll start with Epic systems, and Epic now has frameworks to support the deployment of predictive models and clinical decision support tools. It's our primary EHR here at Seattle Children's, and Epic has a suite of different tools, specifically for real-time predictive analytics. They have a framework called cognitive compute, and we'll actually show this in a bit more detail. That's actually very relevant to the work that we're doing. Cogito is another tool for analytics. It encompasses a set of several databases and analytical engines. Smart on Fire is actually an open protocol that a lot of EHR systems implement, and all of these allow the integration of internal and external models. So actually, Epic has a very extensive documentation available that provides model catalogs, deployment resources that one can read and really understand how to operationalize these model outputs. So if we have a further look into the actual system, here we can see that we can actually display the predictions of the model in the patient list in the EHR system directly. So we could, for example, integrate a deterioration index score and showcase it directly in the column along with the patient list to understand which patient may require more immediate attention. It goes even further than that. We can display inference in the patient's chart, both on the left-hand side in the panel. We can have risk scores, for example, admission or ED risk or diabetes composite index, and have an additional tab open that can be designed to display the historical model outputs, what that score means, and we would need to work with the clinician to understand how this would fit into their clinical workflow. But what's great about this tool is we could immediately output our predictions into the hands of the clinicians. We wouldn't need to deploy a separate system, deal with the maintenance and complexities of supporting it. We could just immediately use the system that's already in place. And a lot of documentation is available. Epic has its own released models. For example, in cognitive computing, they have model briefs, as they call them, specifically discussing model performance, the different specific populations and the outcomes that would very well be used for a process like an regulatory overview or ethics review. So we would very much encourage everyone to look into the systems that you have deployed and how you could leverage them. And now going to idiometry, I would let Jai continue with discussing how that worked out for us.
Yeah, and just in the interests of full disclosure, we have no commercial relationships with either of these entities. In fact, in some important ways, we couldn't be less of a fan of Epic. But the point that we're making is the systems have evolved enough that, as Dmytro says, we focus on our core competencies. I mentioned this vendor-neutral approach with the design of AtriumDB. There are similarly now vendor-neutral archives for medical imaging that allow images from across the enterprise to be pulled into a format that facilitates secondary reasoning. And lowering the barriers to actually doing the work, it feels to us like a gigantic step forward. Idiometry is basically just a data visualization and analytics hosting platform that we have. And this is just another example of how these tools have evolved. What it does in units like ours, getting back to that picture I showed you at the beginning of this presentation, is it provides a subsidiary monitor. This is the patient monitor over here behind the nurse's head, showing sort of conventional waveforms for the patient. This is the idiometry monitor up here in the top left that shows longer trend, essentially sparkline graphics, illustrating the behavior of the time series and allowing a customizable way of looking at trends against one another. Similarly to Epic, this is a deployed clinical tool that now actually facilitates model deployment. They have an API, and in addition to their own tools, it's now possible to deploy tools like ICVS that I just showed using a platform like this. We've blocked out the patient names, on the left side of this screen, and what this pathways view is indicating is essentially what patients are on pathways. There's an explanation of who's eligible for the pathway, what the actual symbol means. This is a very, very, very simple reasoning tool. It's a simple rules-based tool that is trying to limit supplemental oxygen provision to vulnerable neonates. It's showing what the eligibility criteria is, if that exists, what the compliance criteria are, and then at the level of the individual patient, you can actually even drill down and look at what contributed to a given compliance score. And the point that we're making in showing this is, I think that for communities like ours, even though these aren't yet across the board perfect, they serve as a real springboard to solving some of the thorny problems of figuring out how to have a robust silent trial, and then if it's a validated tool in a prospective interventional trial, how to integrate that with existing tools at the bedside and integrate it into existing workflows in ways that don't burden clinicians with additional medical devices or force clinicians to modify their workflow to benefit from a collaborative intelligence. So I think that that's actually probably not just point number one, but the most important of these observations because of the springboard it provides for communities like ours that are interested in pragmatic deployment. I'm just going to quickly run through some of the other specific observations that we would make that we're certainly trying to learn from. The second is one of the reasons to have this really careful appraisal of infrastructure is that it informs key aspects of the rest of the infrastructure that you need to set up. So, if you understand your use cases, and I described some of ours as the introduction and the infrastructure that you have available, you don't just understand data availability, you know what your tooling is, whether you can reason in a primary environment or need to create secondary environments. Questions like latency, data latency, so what kinds of clinical problems might we be able to model in a way that might be clinically useful? And then a real focus of Andrew's work is data integrity and quality, and how to build an appraisal of the quality of the input data into model output in a way that creates essentially auditable AI. I've highlighted the last 2 points on this because, security, access, and governance vary a great deal by institution. And many institutions still struggle with a regulatory framework that is much, much better developed for hypothesis-driven research. And many people on a call like this have probably had the experience of going to their version of the institutional review board, and when they're asked which patients they're interested in, the answer is all of the patients, and when they're asked what data they're interested in, the answer is all of the data, and then getting laughed out of the room. I think if you have a really good understanding of not just potential use cases, but your infrastructure, you're able to more effectively advocate at an institutional level for the kind of governance that facilitates data-driven research, which by definition is iterative, and then ensure that you have the right security and access protocols in place. This next point is controversial and actually might not apply at this point to all environments, but it's certainly now the case in the United States. We have been surprised at the profusion of commercially available and deployable solutions now. As an example, a radiology department utilizes several commercially available solutions that don't just help with things like image annotation and diagnosis, but also the generation of reports that are then consumable by other clinicians. And I say this because I think if you are in a space where you're trying to identify an optimal combination of infrastructural and regulatory approaches for your institution, you should probably anticipate now that your institution is probably going to be either buying or just implementing more available tools that haven't been developed by your institution than building them locally. And I think that with the amount of work in this space and the increasing tendency to actually integrate machine learning into technical systems, we're going to see this just grow over time, with one other example being the integration of GPT-4 and Epic. This is another philosophical point that we feel strongly about here in Seattle. The concept being that the approach to infrastructure must facilitate convergence. Now, this is not just a really parsimonious way of using everyone's limited resources in developing these infrastructures. It also is a way of providing operational models of precision medicine. Traditionally in medicine, we administer research and patient care like they are two separate use cases. And in clinical environments, that creates all kinds of headaches for us. Many research institutes affiliated with clinical hospitals are administered differently, sometimes on completely different campuses. That's the case here in Seattle. We'll sometimes have completely different infrastructure groups, IT groups, completely different sort of data repositories. And the challenge with that is it creates a situation where you're really not ready for a scenario where you might start with a research and development tool that performs well enough that you want to deploy it clinically. The process then of taking something from what was a research framework and configuring it to deploy in a silent trial where you can evaluate it against an actual clinical use case involves this very, 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 very heavy lift. And this is the problem we encountered when we were at SickKids. We feel strongly that research infrastructures, if there is a potential for deployment, should have the characteristics of the production environment. So it's easy to port a tool from the development environment into a production environment. I would say that another area that has been a learning experience for us is, I mentioned our focus on the continuous high frequency data. Because of our sort of infrastructure first, if you will, approach that was informed by use cases in Toronto, we didn't pay enough attention to our ability to access all kinds of other data that provided the time series with the context. And what that resulted in essentially was a little bit of a technical silo and a failure early in our experience to create concerted action around an enterprise-wide approach that would make every type of data available. Because for almost any group working in this space, regardless of what sort of specific use cases you start with, the goal over time is to reason across more and more and more data types in more and more and more multimodal models. And so, another sort of core tenet of the approach that's being taken here at Seattle is to make sure that whatever general set of considerations are being employed, we're anticipating a need to reason across all data types. This is a simple point, but is also worth emphasizing. And, in fact, the change management piece in some ways can't be emphasized enough. Quite often, if you're in an environment where you have to do some version of what I just described at the beginning of this presentation with AtriumDB, you don't just create a little bit of a data silo. You might intentionally do that so that you can work in a more agile way than the institution as a whole will allow. I think that there are all kinds of compelling reasons in the moment why that seems like the right strategy. I think at a higher level, it's the wrong strategy. And that's because when you get to a point which we arrived at in our experience at SickKids, where we thought that we had things that were ready to be evaluated in silent trials against clinically relevant use cases, the entire rest of the infrastructure that needed to be in place, the regulatory infrastructure, the kinds of relationships that needed to exist with IT, the sort of awareness that needed to exist at administrative levels in the hospital didn't exist. And then you are delayed by anticipatable need to build relationships. So involving stakeholders, even defining who those folks are and trying to evolve in a convergent way as an institution, I think is a key priority. And then as an extension of that point within the modeling community at your institution, create community. Building upon the point about data silos, it's surprising to me when you interact with folks in the community, how many people have different groups working in a modeling space in an institution that aren't necessarily sharing intelligence with one another or converging on approaches that function almost like competitive groups within an institution. and Dmytro and I, among others, here in Seattle, have been really trying to create community, with the concept being that that provides us with several benefits: the ability to, again, converge on the infrastructure, share best practices, coalesce around standards that'll make everybody's work more ready to be evaluated if it proves to be clinically useful. And then, obviously, in this sort of relatively more straitened economic environment, be parsimonious with resources, not duplicate existing efforts. This is actually again a simple but very important point. A lot of those of us that work in this space that are interested in complex research and development use cases can tend to dismiss simple operational use cases as being either insufficiently interesting or not innovative enough to be important, uses of our time and effort. This is an example of sort of two of these general buckets of work: so robotic process automation or agentic workflows. I actually think that that's a mistake as well, and the reason that that's a mistake is my suspicion is that operational use cases are not just going to be use cases that become ready for deployment much more rapidly than clinical use cases. I also think that they are probably going to be much more compelling in making arguments for enterprise infrastructure to hospital administrators. In other words, this is where the return on investment for hospital leadership comes from. Another key consideration is how you develop a model of sustainability. This was something else that I think in my early experience, I don't think I thought enough about. And much of the work of creating what was intended to be a hospital infrastructure relied on competitive grant funding. And that isn't to say that that isn't a really important component of the funding model, but that's the difference between sort of capital and operational funds. And to develop a sustainable infrastructure, you need operational funds. There are all kinds of really interesting ways programs have approached this. We know of at least two programs here in the United States, getting back to that set of operational use cases that I just highlighted, that have partnered with hospital administration to develop areas of potential optimization, and then identified sort of a cost model associated with that optimization, and being able to negotiate if they are capable of deploying some meaningful solution for some fraction of costs saved as a mechanism of ensuring the sustainability of this infrastructure. I think it's an interesting way of trying to approach this problem, sort of a goal-directed way, and is something that, at least in the two examples that I mentioned, really speaks, it seems, to hospital administrators. I mentioned the development of our technical system occurring in something of a silo, and increasingly in the landscape now, and this gets back to the points that Dmytro was making about the improved tooling, is you will need industry partners. There's really no way of scaling these interventions or validating these tools in multi-institutional deployments without some sort of partnership of that sort, and identifying who you're going to partner with and under what circumstances is also something that I think is a very important part of the longitudinal process. And then I'm going to end by saying, one of the reasons that we were gratified to be invited to chat about this is I don't think that there are enough conversations about how to actually do this. And I'm hoping that any for share intelligent. We are a community, and I think we should be doing, and not the ways we'll the questions you have.
Sorry, Jai, can you hear us?
I think Jai might have had some problems with
Okay.
with the internet connection. But yes, the last point was that we think that the collaboration is very
No,
important.
yes, I couldn't for a minute there.
Okay, perfect. So we can now move into the Q&A session, Melissa. So we'd be glad to take any questions from the group and follow up on everything that we've discussed and more.
Awesome. Thank you so much. Jai, one of the things that I always reflect upon with you is you really know how to turn a phrase. So there were a lot of really great phrases in there that impacted on me. And I'm also reflecting on the fact that all of the kind of principles that you alluded to, it was really comprehensive. And we've got folks on the call who are from our consumer group at Women's and Children's, our partners in Aboriginal Health, and people from all over the health networks. So I'm going to take chair's privilege and open up with one of the first questions that sort of came to my mind. And I'm guessing Jai had to hop off and then back on again. But Dmytro, one of the things that I was wondering if you could talk a little bit more about is because I completely agree that I think as we move forward, there's going to be this need for sort of just-in-time, adaptive, rapidly mobilizable teams that can evaluate these solutions in local institutions. And so one of the things for me that obviously is probably one of the most important things we can think about is fairness and making sure that we're going to enable our clinicians to appropriately calibrate how they work with the model such that we're promoting equity, however that exists within an individual context. So I'd love to invite you to comment a little bit about that.
Yes, it's a very important it's a very important question, and one that we're looking at very closely as well, because with any AI implementation, fairness and ethics and the bias analysis is our considerations that should be top of mind, especially in this pediatric setting. So the way we approach this is first of all, we have, I think there are multiple ways how we can approach that question, but first of all, we have, from the development standpoint, a robust process, I believe, where no model moves into even into the testing before being evaluated across multiple different attributes. So we first look whether the model is even accessing protected health information and which specific data points it's requiring for the prediction. Sometimes it's, as in the ICVS example that Jai was showing during the presentation, we're just looking at the waveform, so arterial blood pressure or others. There is little to no access to some protected health information. So in that case, it's the bias analysis. We would just need to look at the different cohort levels and understand how the model performs. But in some cases, we need to access patients more. Other patients' attributes, and we need to understand how the model, whether the model is biased or not. So we do some, we try to make the models explainable, and one of the ways we're for example deriving Shapley values is a method in machine learning that can help the model understand the model and what factors have influenced the prediction, and we would be looking at which factors contributed to the output and whether or not the model is biased. That's one side of things. We're very carefully looking at this question from the development standpoint, but the other is the institution itself has the regulatory body, which in our case is called the AI Review Board Committee, and it's similar in structure to IRB, but IRB is includes members from the different areas of the institution. So it includes all of the voices and key stakeholders that need to have a say in how the model is being developed. So it would include some representative of patients, some representative of clinicians, legal stakeholders, and clinical, of course. So all of these key people would have a say and overlook how the model is developed and give key and structurally recommendations if there are any concerns about the implementation, and this body would follow the development and basically monitor how the model, whether the model is equitably deployed.
Jai, I was just asking about fairness. I don't know if you want to add anything to what Dmytro has said.
Yeah, I do. I apologize for the degeneration of my internet connection. I don't know if you guys can hear the karaoke party happening in the room next door with my girls. I hope not, but that I assume is what's consuming our bandwidth. I actually I want to emphasize the last point that Dmytro made about the institutional body, because I found that to be something of a surprise here. The institutional review process was much more robust than I expected, and occurred with individuals that were not just stakeholders, but stakeholders with a real ability to influence the institutional approach. So as an example, the vice president of what used to be called equity, diversity, and inclusion in the United States before the Trump administration outlawed that, is one of the people who participates in this session and ensures that any model that we're considering, conforms to a preset set of institutional standards and isn't going to basically encode bias in our system in a way that further harms already disadvantaged groups.
Thank you for that.
And that process,
resonates.
as Dmytro is saying, that process is actually subject to subsequent review, which I think is also a very robust mechanism. Meaning it's not enough to come and make an initial presentation and reassure everyone. You actually have to come back and show your results.
That resonates a lot with the work we're doing at Women's and Children's. Many of our committee members are actually on the call today. One of them is actually Ashish Sharma, who's one of our consumers. And he asked how much percentage, or how much roughly, did you have to customize or modify the AI model framework or learnings at Seattle compared with what you had at SickKids?
So that's a fascinating question. And the honest answer to that is we don't yet know. And the reason we don't yet know is because, as I was sort of explaining in the first half of the talk, we've actually chosen initially to deploy mechanistic models. This is a bit of a tangent, but a relevant tangent in medicine. Medicine is challenging from a modeling standpoint for multiple reasons, one of which is a lot of hospitals as technical environments are a little bit of a house of cards. There are lots of different technical systems of different ages. There's investment in technical systems, even if they are, sunk costs that doesn't allow them to sometimes be reevaluated, even if they aren't the best tools to provide a logical output. One of the things that has been very helpful to us here is that the actual front-end technical systems here look very much like the front-end technical systems at SickKids, so patient monitors, ventilators, et cetera. And so my hope is that we will find that there actually aren't at least technical reasons why we need to substantially modify models. There are very different patient populations, though. And getting back to your question about fairness, I think that's where much of the diversity will be seen.
I would also add to that the environment that we're operating in is quite different in terms of the technical infrastructure. At Seattle Children's, a lot of the data is already moved into Google Cloud Platform and some of our other cloud partners. We have other technical enablers here. So and as we mentioned in this presentation, we tend to use the existing resources to a high degree to make our lives easier with the deployment. So we wouldn't completely rebuild what we had at SickKids, for example. We would use what exists now. So in that sense, a lot of the things are different. And I feel that also the ambition and the ideas that we have also evolved now, especially given the environment, given the fact that we have one of the largest regional programs available. We would like to scale our care beyond just our center, but to others in the region, and that involves a whole set of other technical questions and approach to AI implementation than what we had at SickKids. So it differs in a few ways, but it also remains a lot of key lessons learned from the SickKids experience, as we shared today in the presentation, still remain.
You can see me nudging my cognitive science and human factors colleagues over here. It's one of the best things about coming here actually is had the opportunity to work with Dr. Carolyn Semler and her student Lana Takomarov. I know, we've talked a lot about how human factors is so important, particularly in an environment like the ICU. I think this also leads to Tim's question about looking at technical comfort or understanding within staff. So I want to invite Lana to comment.
Thanks, Jai and Dmytro, for your presentation. It's really, really interesting, and the stuff that you do just feels so advanced compared to here. Sometimes we're still getting there, but even just looking at the EPIC interface, had so many interesting thoughts. But anyway, so Carolyn and I are colleagues of Melissa. Well, I'm Melissa and Carolyn's student. I'm not really a colleague yet. Haven't earned that. But later on. But we have a question regarding the human factors element, and that is what kinds of evidence do you have of improved reasoning on behalf of clinicians using these tools aside from just self-report? Is that purely by getting evidence of improvements on clinical outcomes for patients, or do you do any other, I guess, vetting or processes there to look at improvements in reasoning?
That's actually that's a really interesting question. The models that we were describing are all not yet deployed in a framework that we are asking clinicians to utilize routinely in decision making. When one of the last sort of specific questions that I was really interested in at SickKids that gets to this question that you're asking is essentially how you measure the efficacy of a collaborative intelligence, because that's what results. The concept is you have a human intelligence paired with an artificial system, and if that is the outcome of deploying a model, how would you assess, one, if that exists, and then B, if it's efficacious? I think it's probably multidimensional, and the argument that we made at the time that still feels like the right argument to me is that there are sort of empiric domains associated with task performance, patient outcome, maybe even resource utilization, time to insight. You can imagine any number of very granular empiric endpoints that would measure the efficacy of the collaborative intelligence. I think measuring the compatibility is a much more subtle and interesting question. And at the time, we were really interested in the concept of trying to get objective measures of cognitive load. The concept is that you can measure things like pupillometry, skin galvanometry, and use those as proxies for sympathetic activation, because that does correlate with cognitive load. And then basically do a comparative study of task performance with and without the integration of the model. And theoretically, collaborative intelligence should decrease the cognitive load associated with complex tasks, or at least that's what we believe. And so that'll be the way that we will proceed here, unless we get smarter in the interval between now and then, when these are deployed and consumed by clinicians.
One interesting example that the team here at Seattle Children's has been deploying is ambient AI, which a lot of us in healthcare have now heard is getting rapid adoption. And the way they measure the performance of the tool and the feedback from clinicians is quite interesting. Is basically they notice that it doesn't save. And maybe I'll add some context. So ambient AI is basically a little tracker, a speaker, a microphone that records the conversation during the patient encounter and keeps keeps notes basically, and populates the chart for the clinician. And the way the performance of this tool is being measured right now during the trial period is we're looking at the time of the encounter. It hasn't decreased. It actually even increased a little bit because the provider needs to read the documentation that the AI tool has come up with and added that. But what we see is providers actively share that they love the tool and they really enjoy using it because it reduces from the cognitive load when they're meeting the patient. So they think more about the patient and can focus better rather than constantly thinking about remembering the key events that they need to put into writing. So that's an interesting example. But what we're also looking at is how much of the notes that the AI has generated has been changed. And I think it's also a great factor because if the provider is just copy pasting or just saving what the AI tool provided, it indicates a problem. Maybe the provider didn't actually review everything accurately. And another problem exists if too much of the note is being changed, then it means that the tool is not performing well. It's actually not saving time, but adding too much complexity. So there needs to be a balance, and we're just looking at the number of words that in the sentences that have been changed. So I think it's just an interesting example that goes to show how we think about the adoption and how we measure the success of these applications.
Yeah, that's really interesting. I think it's really great that you guys are even thinking about it and how you might conceptualize like measuring those sorts of things. I know from our perspective, it definitely feels like the Wild West out there when it comes to human factors and CogSci. And, you know, we're still really trying to work on, I guess, like marrying a lot of fundamental concepts from those fields to clinical outcomes and very specific use cases within medicine. But yeah, I mean, Carolyn and I were just talking the other day about with so many unknowns, like where do you really start, and like the idea of problem scoping. And so the type of the algorithm really determines the type of cognitive tasks that they're doing. And then I guess like the potential, or I think the things you're describing here, they're sort of like unintended changes. Sometimes they're consequences, sometimes they're not as negative, but they are unintended changes. And so it's really good that you're monitoring that. And yeah, maybe we'll talk more sometime. I'm winking at Melissa right now.
Well, you know, I'll actually add one other thing about that, and I really appreciate that you brought that up because I think that this lens is really important when thinking about what a robust prospective interventional trial looks like. And that's because, you know, as anybody who works in this space knows, the deployment of the model is not the only change to the clinical environment. You've modified the task, you have done even subtle things like modified clinician attention. And so it's the model is just one piece of a hierarchy of potential changes. And if you are to evaluate, you know, process, maybe balancing and outcome measures, I think your trial design has to account for all of those changes.
And I think to answer also Tim's question about how do we build trust and ensure adoption when there's a range of technical comfort and understanding among clinical staff, I think one of the ways we go about this is it's important to identify clinical champions for a solution that we're looking to deploy. And of course, we need to deploy the tool equitably so that it's available for all of the clinicians to be used. But at least during the trial, there are some, we're very much looking to recruit the clinical focus group the clinicians that would be working with us during the development phase and the validation phase of the model on a weekly basis and reviewing what the results are, how the tool performs, and they would actually become early users. They already have this, they feel close and invested into the development process, and they then tend to use the model also among the first ones among the clinicians. So they will later on share that knowledge and experience with others, and more people will start using. So it's not an obligatory process where we force clinicians to use the model. It's more about training and sharing and making sure that everyone understands the capability that exists and sometimes a modified clinical pathway. But it's a lot about working with clinicians and making sure they're comfortable, understand the specific output, and then it's up to them to start using it.
It's also why it's so important to converge on the existing platforms that clinicians use. And that's why the evolution of the tools are important. You're not asking clinicians to do things that they're completely unfamiliar with technical systems that they're completely unfamiliar with. And that's why highlighting the deployment capabilities of existing clinical tools, I think, is important.
Yeah, almost like you need an intervention ensemble. I feel like someone wrote about that. All right, thank you so much for your time. This has been an absolutely incredible talk. Really appreciate all of the wisdom that you've shared with us. I'll send a final nudge about the Next Generation Responsible AI Symposium. I mean, if you guys want to submit and come down to Adelaide, that would be amazing. So with that, I will say thank you again. Thank you to everybody for attending, and stay tuned for the next AI on the Ground.